This is 1.8, Part 1, Exploring Transformations. A transformation is a change in the position, size, or shape of a figure. There are 4 transformations that we will apply to functions. Today we are going to be looking at horizontal and vertical translations and then reflections. So first, let's look at our first type of transformation, and that is going to be called a translation. Translations occur when a point or a figure moves in the same distance in the same direction. So again, this can be applied to just a single point or all of the points in a single figure. A horizontal translation is where you are moving right or left. So horizontal, right or left, and this applies to the x coordinate. So think of the x-axis being your horizontal axis. If you look at this graph down here, your horizontal axis is x. So if you're moving left, this h value here is going to be negative. You're subtracting that number from the original x value. If you're going right, your h is positive. You're adding it to the x value. So your original point is x comma y. If you're moving to the right, it'll be x plus h comma y. If you're moving to the left, it'll be x plus negative h comma y, or x minus h. Then we have vertical translations. These move up or down. This changes the y coordinate. So think of your vertical axis as your y axis. So a vertical translation up or down will change your y coordinate. So if your original point is x comma y, your new point will be x comma y plus k. And again, if you're moving up, k is going to be greater than 0. You're adding that number. If you're moving down, k is negative or less than 0. You are moving it down. Perform these given translations on the point -3, 4. So it's helpful to see these visually first, and then as you get more used to them, you can just add numbers, add values to the original point or points. So first, if we start at -3, 4, we want to move 5 units to the right for this first translation. So we start at our point and count 1, 2, 3, 4, 5 units to the right, and we end up there. That point should be 2, 4. So since we're moving 5 units to the right, that means our x value is going to change plus 5 units. We didn't do anything to the y value because it didn't move up or down. So if we start with -3, 4, we translate it 5 units to the right. That's going to be -3 plus 5, 4. We end up with 2, 4. And that's where we ended up when we drew it out. All right, next, we're going 1 unit left and 2 units down. So let's start at our point -3, 4, 1 unit left, and then 1, 2 units down. And it looks like visually, we should end up at -4, 2. All right, so if we're going 1 unit left, we're taking 1 away from our x value, -1 to the left. And 2 units down, we're subtracting 2 from the y value. So if we start at -3, 4, you're going to subtract 1 from -3, so -3 minus 1. And then subtracting 2 from the y value, so 4 minus 2. And when we simplify that, we get -4, 2. And that's where we ended up when we did it on the graph. So 2 different ways to do it. You can graph it out. If you start dealing with points that have bigger numbers, it's going to be easier to just try and do the arithmetic behind it like we did over here. All right. Next, we can also translate whole figures. So here we have this M-looking figure. And what we're going to do is use this rule. If you're asked to write a rule, that means you're writing it in words. So we're asked to use this rule to perform the transformation of this function, this figure right here. So first things first, you're going to want to find some points to translate. So I'm going to pick 5 points here. Could be any 5 points. I like to make them kind of spaced out so I can see the shape when I'm drawing it out. And then we're going to label those points in this table. So this first point here is -4, -2. So the x is -4, the y is -2. Here, our x is -2, and our y value is 0. Here, our x value is 0, and our y value is -2. Over here, our x value is 2, y value is 0, and then here our x value is 4, y value -2. Okay, so now let's write our rule down with our x's and y's. So if we're translating 1 unit to the right, we're going to add 1 to our x value, moving in the positive direction, right? Right is positive. 2 down means we are moving y -2. So moving 2 down in the negative direction. So we -2. All right, then from there, let's translate our points. So we're going to add 1 to every x value, subtract 2 from every y value. So the new point in this case is going to be -3, comma, -4. -4 plus 1 is -3. -2 minus 2 is -4. Add 1 to the x value, so -1. Subtract 2 from the y value, -2. Add 1 to the y value, 1, or x value, excuse me. Subtract 2 from the y value. That becomes -4. Add 1 to the x value, 3. Subtract 2 from the y value, -2. Add 1, 5. Subtract 2 from y, -4. All right, then we can graph these. So -3, 2, 3, 4, -4. So down here. And then -1, -2. So right here. 1, -4. 3, -2. And then 5, -4. And then since our original figure had the lines connected, let's connect those. And it should, if you were to actually physically translate each point, then you should end up where we are right here. So this point right here corresponds to this one. So let's double check and make sure. 1 to the right, 2 down. Perfect. Let's see if this point corresponds with that one. 1 to the right, 2 down. Good. 1 to the right, 2 down. Perfect. 1 to the right, 2 down. That one worked too. 1 to the right, 2 down. Okay? So you can do it visually. If we do have more complicated figures, a lot of times it's easier to try and do it in a table like this and organize it that way. So those are translations. We are also going to look at something today called a reflection. A reflection is a transformation that flips a figure across a line. Each reflected point is the same distance from the line of reflection, but on the opposite side. So we're just looking at reflections across the x-axis and the y-axis today. Okay, so reflection across the y-axis, that's where your x-coordinate changes. Your x-coordinates are becoming opposite. So if your original point is x comma y, your new point would be -x comma y. A reflection across the x-axis is where your y-coordinate changes. Okay, so, and it becomes opposite. So your original point is xy. So then if you're reflecting across the x-axis, your new coordinate will be x comma -y. All right, so for this one, write the rule and then use the table to perform the transformation. So this is similar to what we did in our last translation example. So we're going to want to find a few points. All right, so we have enough room in the table for 5, so I'll do 5. 1, 2, 3, 4, and what one do I want to do? We'll do this one for 5. All right, so let's write them out here. So we have -4, 2, and -3, 1, and then -2, 0, 0, 2 right there. This point over here is 2, 4. All right, and then our transformation here is a reflection across the x-axis. So we are reflecting across the x-axis right here. So that means our y-coordinate changes. So our y values are going to become opposite of what they were when they started. So this point of -4, 2, well, first let's start. So the point xy will become x, comma, -y. So this first point here, -4, 2, is going to become -4, -2. This point right here, -3, -1. This point right here, -2, 0 is neither positive or negative, so that one will stay the same. 0, 2, 0, -2. And 2, 4 will become 2, -4. All right, so let's graph those out. -4, -2, -3, -1, -2, 0, 0, -2, and 2, -4. So then if we connect those points, you should be able to see that this is a mirror image. So what we were looking for here, like it says in the definition, is each point being reflected over a line. So since we're going over the x-axis, we're reflecting over this purple dotted line here. That's the x-axis. So if you look, each point on either side should be directly opposite each other. So if you look, this point right here is 2 away from that line. This point down here is opposite it, 2 away from that line. Okay. This point here is only 1 away from the x-axis. This one is 1 away from the x-axis. All right, so you can see each point is the same distance from the x-axis on opposite sides. Now let's try this with a reflection across the y-axis. So why don't you pause here and see if you can find 5 points, and actually it's the same graph to start, so you can use the same 5 points, and see if you can write the rule up here on the table for a reflection across the y-axis, and see if you can get your points. So pause here, try that, and then come back and check and see if you did it right. Okay, so hopefully for your points, you could have chosen the same points because it's the same graph that you did up here. And then a reflection across the y-axis now means that you are making the x value the opposite. So your new coordinates are going to be -x, comma y. So all of your x values are going to become opposite of what they were. So -4, 2 is going to become +4, 2. -3, 1 becomes +3, 1. -2, 0 becomes +2, 0. 0, 2 stays as 0, 2 because 0 again is not positive or negative. 2, 4 becomes -2, 4. All right, and you can see here on the graph, they are in fact getting reflected the same distance across. So if you look, the y-axis now is our line that we're reflecting. So each point should be the same distance from that line. So if you look here, the point that makes the V for each of these, this point over here, the original point, is 2 to the left of that line. The reflected point is 2 to the right. All right. Over here, our original point right here, this point 2, 4 is 2 to the right of that line. And the new point, -2, 4, is 2 to the left. It's just 2 in the opposite direction. So you can check and make sure that you've done that correctly by making sure each corresponding point is the same distance from that reflected line or from that line of reflection. All right, so that covers translations and reflections. Try your practice for 1.8 part 1.